of course, yeah. Only thing is, Rajgaru reduced my age by 10 years. He told 3.5 decades. I'm having almost close to 44 years of experience. In a way, thanks to him, I've become 10 years younger now. Okay. So I have 44 years of work more or less in supply chain, managing supply chains to creating supply chains to dealing with the automation systems like DCS and process control systems, and then moving on to IT systems like ERP, then BA, then of course what we are calling it as traditional AIML solutions. As on date, we are working on this agentic AI. So what we would be doing is we'll uh, slightly touch upon the second one and third one very, very quickly. How the manual manufacturing operations started long, long back, how they used to be before 1970s, and from 70s to till now, how the manufacturing progressed from manual to agentic. We'll just touch upon why I've put some slides on that on this topic is to ensure a sort of logical progression to our presentation. Otherwise, there is nothing much all of us know about it. And in any case, this presentation, I'm sure IPQC will be forwarding to all the attendees. And then we'll be talking about supply chain elements. Here also, we'll go very quickly. What is supply chain management? What is supply chain operation? What are the different elements? So, what is meant by a strategic, tactical, and operational elements of supply chain? What is driving the supply chain? And what is that I want to achieve? In fact, I always used to say there is only a small piece left to the right and left of the supply chain. Otherwise, supply chain is nothing but business chain. And if I'm able to gain control over my supply chain, more or less, I'm gaining control on my complete business. So, what is that we will see again very, very quickly. Most important is basically the next one, agentic AI. What is this agentic AI? Everybody is talking about. Here, I want to say one point. When IT started long, long back, there used to be, I started my career way back on 1st September 82 in BPCL. IT used to be different. We domain guys used to be different. And the refinery DCS guys used to be different actually. So IT is information technology, OT is you call it as operating technology or operational technology, and domain guys are domain guys, of course, the refinery process guys, the marketing guys, the sales and distribution guys, so on and so forth. So all these three, they used to completely used to work in silos, the IT, OT, and domain. So over a period of time, how we know slowly lot of convergence started coming, and now with agentic AI in picture, in place, how actually all these three have completely converged into one. One more point I want to say here is, of course, when we are talking about a new technology, say for example, when I'm talking about the AML solutions, though I've used traditional AML solutions, it's not that actually, I'm completely discarding what I have and moving on to agentic AI. It's not like that. Traditional AML, then comes large language models, then comes AI agents, then comes agentic AI. Similarly, in traditional IT as well as in OT also. So, what is this agentic AI and how all that is converging into this? We'll see that. Then, since our topic is agentic AI for supply chain operations and management, we'll be again looking agentic AI. After knowing a bit about agentic AI, we'll be looking how actually agentic AI fits phenomenally, fantastically into supply chain. One more point I want to say here is uh, why I touched upon that domain, IT, OT, operating in silos, and slowly they started converging. Other phenomena what I have seen is when IT started progressing, By the time ERP applications came into picture, predominantly the ERP implementations used to depend majorly on the domain, on the functionality. So you have a SD module, you have a PP module, you have a MM module. So we used to draw people from all these functions, from production, from sales, from materials, from maintenance, etc., etc. When actually we started talking about AI, ML, big data, artificial intelligence, and machine learning solutions, the reliance on domain to state a problem and help in finding a solution has increased. Domain's prominence has increased. Now, what I am seeing with the agentic AI, it's predominantly the domain that is going to rule. So, why I'm saying this point is, I don't know the profile of this group, but I'm sure there must be a lot of guys from a domain heading MSME, in different capacities. So they all should be happy with this. And of course, is a great responsibility on their shoulders, and they just can't leave it to IT, because there is no IT, there is no OT, there is no domain now. All three are actually converging into one function. Then we will look into some of the AI/ML solutions. Then we will look into what are the AI agents in supply chain management. And of course, again, after agentic AI for supply chain operations and management, this multi-agent systems in supply chain management, agentic AI, that's also very, very important. Probably, we will have this for 1 hour. It's 10:45 now. 10:45, sorry, I'm talking from US, that's why I'm saying 10:45 p.m. So it's basically 11:15 a.m. there, correct? So 12:30 means, I'll talk about 1 hour, and last 15 minutes we'll take Q&A. And we also discuss briefly about what should be the next steps. Okay. So what I request is, probably please allow me to complete this uh, 50 minutes to 55 minutes talk on all these points. So bear with me, and please hear me. I'll try to be pretty slow, and hopefully I'll make sense when I'm talking. Then, if you have any questions, you can ask me. Okay, that would be a better way, rather than trying to ask questions in between, because I really want to complete these slides presentation, so you will go back with some understanding, and probably with some plans of how to get into this agentic AI in your companies. Okay, so let's go to the next slide. So I'll go very quickly here. Absolutely, long back we started manufacturing with manual operations. How we moved from manual to automation to autonomous to agentic manufacturing. So I'm giving this deck to you, so don't worry. So how the basic mechanization has taken place, and how that basic mechanization in form of OT, IT, and what is the business impact. We have written for all these three: basic mechanization, the OT, the IT, and the business impact. Similarly, what sort of industrial automation has taken place. Industrial automation, it moved from manual operations to basic mechanization. It moved into industrial automation to integrated automation. What is meant by integrated automation? All that So I'm not going to spend time on that. Then we all know about Industry 3.5 and Industry 4.0. And Industry 3.5, Industry 4.0, and hyperautomation, not much of a difference actually. So if you see the business impact under hyperautomation, end-to-end process automation will significantly reduce human intervention. That's what. So that is where actually we are able to talk a lot on optimization and prediction. Uh, Still, we were not talking too much on prescription, and we are not talking about autonomy and autonomous during hyper automation state. If I have to say, I'll introduce a word called contextual intelligence. So yes, I'm able to optimize my supply chain optimization. I'm able to predict demand forecasting, inventory modeling, MRP optimization, or transport cost optimization. Or I'm able to do plenty of process optimization even on OT front also. But what is happening is a human is required actually to validate that. And other important concept I would like to introduce here is they're all deterministic. All AML solutions are deterministic, but we are dealing with plenty of uncertainties. Uncertainty means probability. There are a lot of risks around us, and when they occur, we don't know. If they occur, actually, what should happen, we don't know. And second thing is supply chains are no longer linear, supply chains are circular. So in this context, actually, we need to move into a sort of state of agentic manufacturing. What are the agentic manufacturing we will see as we go along. But I request you all to see the business impact actually. Okay, zero touch operations where human roles shift to high level supervision and exception handling. Otherwise, in short, agents are nothing but our teammates, our digital teammates. Okay, I can call them as the workforce, digital workforce, or I can call them as intelligent workforce. So they are domain specialists. Okay, so we deploy them in different areas, across the supply chain or across the business, and they not only do their job, they collaborate fantastically amongst themselves. That results into some sort of autonomous orchestration. What is that, we'll see as we go along. So what I do is now I will quickly uh, pull up the slides very fast. The evolution path is okay. This is just a beginning to the presentation. That's why these slides are put here. And you see how the convergence is taking place. Now the total integration of OT and IT is taking place. Okay, with the agentic platforms on one side, OT transformation with the AI agents on the other side. Yeah. Now, yes, this is also very familiar to you. What is supply chain actually? Yes, I need not tell. On your extreme right hand side you have customers, on the extreme left hand side you have your suppliers, in between you have your processes. Okay, you may start with make to order or make to stock. There is demand. The most important task for any company is to meet the demand, order fulfillment. The customer has placed demand, customers have placed demand for several products. Say for example, they requested for delivery dates and you have agreed. Once you have agreed, that becomes a sort of absolute sanctum for you. You need to do everything possible to adhere to that. In our language, we call it as GATP, Global Availability to Promise. So what is that we need to do? You can come from that side to this side. Okay, the customers have placed orders, finished goods. Then you need to produce them. To produce them, you need to have production capacities, and you need to have storage capacities, and you need to have maintenance in place. And of course, most important is you need to have procurement. For procurement, you need to have suppliers. And to bring the raw materials, you need to have inbound logistics. And to ship the finished goods, you need to have the outbound logistics. So not only this, but there is a complete ecosystem around this, around the supplier, internal process, and the customer around it. The competitors are there, the regulatory is there, geopolitical conditions are there. So many uncertainties, so many factors that influence each of our supply chain elements. So I I told all this. Actually, my style is basically, to say the content of the next coming 3, 4 slides also. So this is all what core elements of a supply chain. You know all this. We need not go to the basics actually. Of course, plan, source, make, deliver, return, enable. Okay. What is that we are enabling? We are enabling here the costs, the finance, okay, the HR, so many of them. The most important is here again, I need to have control over my costs. I need to have control over my profits. I would like to maximize my profits and have good control over my costs, the cost of goods manufactured and the cost of goods sold. I really, maximize the value of these two. Seriously, one is minimization, other one is maximization. How I'm going to do that actually? That's the name of the game. Okay, what are the key responsibilities? I already talked to you about, strategically, what is supply chain network actually, how you are going to design the network, and what is meant by network optimization. I'm able to estimate my customers' demand quite well, but when it comes to procurement, I'm all over the place. I'm not able to procure from the right suppliers at right price at right time. I'm not able to bring that into my uh, factory warehouses through the best transport mechanism or route. So there's no point. Otherwise, I'm doing quite well in my production, but I'm actually screwing both on estimating my customer demand as well as procurement. So all these actually would result into chaotic situations. So I'm not doing any great optimization throughout. So why I'm saying this is, here I want to introduce one good concept for you that would be very very useful when we talk about agents. One is local optimization, the other one is global optimization. Okay, local means at demand level, at procurement level, at production level, at maintenance level, at distribution level, so on and so forth. But if I need to achieve, if I really want to maximize my profits and minimize my costs, I need to have my entire network optimized. So how we are going to do that network optimized, and how many unknowns are there, how I can deal with unknowns? I can't. Even AML algorithms are not able to deal unless we are able to actually produce agents and allow these agents to collaborate amongst themselves. Okay, so that's what we will see, but I'm just telling you upfront itself, what is meant by an agent and what it would do. Then what are the modern supply chain trends? Probably the digital twins. In fact, here you need to see from a multi-agent system, or from a agent perspective. A digital twin is slightly different actually. A digital twin is there to do simulation, is there to do prediction, and is there to do optimization. What is that? We will see. A digital twin plus a multi-agent system both actually result into a self-optimizing supply chain. What are that? We will see. Otherwise, rest of the things completely. Nothing need elaboration. Okay, now we will go to what is agentic AI. Okay, so I'm sure you must be hearing a lot about agentic AI, and everybody says, what are you doing? I'm building agents. It's not all that easy unless somebody has a very very good domain background, because I can build a demand planning agent for a pharma company, or I can build a inventory agent for an oil and gas company, provided I have worked in pharma, provided I have worked in oil and gas company. Okay, why? I'll tell you as we go along. So if you see what is agentic AI, again, if you are able to read it, if I start reading all this, it would take a lot of time. But I'll say actually, you please remember this. You remember this as PRALC. Okay, P is basically perceive. R is reasoning. A is act. L is learning, and C is communicating. Okay, so the agentic AI systems, they perceive, they reason, they decide, and act autonomously. You all know what is meant by autonomously. There are no guardrails actually. There's nobody stopping. They deal with complex workflows. Agentic AIs. What is a complex workflow? Demand forecasting is one aspect of the business. Procurement is another aspect. Production is another aspect. Inbound logistics and outbound logistics is another aspect. Say, let us take only these four for the time being. So these four are four different workflows. Forget about the workflow what we know from our ERP days. Okay, these workflows I'm talking are different. They are complex workflows, and Agentic AI travels across all these workflows, takes correct decisions, right decisions. So it optimizes, it predicts, it simulates, and it would actually arrive at what is best at that point of time by taking each and every aspect into account, a 360-degree angle. Okay. So then continuously learns and adapts to changing conditions. It is not adopt, actually it is adapt is basically learning from the environment. Plenty of flexibility, learning from the environment. Okay. Combining the precedent with anticipation. Okay. Prediction means basically, it is taking the past historical data, combining with a lot of other features, coming out with a model, and that model predicts what would be the future values. Okay. So I told you, like a few minutes back, behaves like a digital worker capable of a multi-step workflows. Okay. So then integrates LLMs. You all know LLMs. I need not tell, actually large language models what they do. Yeah, here one more point I want to say. What is happening in IT world now, rather in manufacturing world or in enterprise world, almost all companies, they have automated their transaction processing systems with one or the other ERP system. Very big companies have gone with SAPs and Oracles of the world. Small companies have gone with some local ERP systems. Some even have developed. So there are ERP systems, and of course, to some extent, the factory operations have been automated with the process control systems. Okay. Now, on the top of these ERP systems, we have these BI systems. So what is BI system doing is plenty of data that is getting generated through this DCS and ERP is being converted into information. But there are not many systems capable of actually converting this information into interpretation. That interpretation into a sort of actionable intelligence embedded action items. That is not there. Okay. So, what our level one here is, uh, with the advent of big data, ability to handle large volumes of data of various types, structured and unstructured, combining with terrific algorithms that are available, able to allow this data to be consumed by algorithms and get into a sort of optimizations and predictions. Okay. So I gave a lot of examples: MRP optimization, production routing optimization, or condition monitoring. All of us are familiar with condition monitoring, the edge computing, or assessing the remaining useful life of the machine, so on and so forth. So this is the first level, actually. After this ERP, BA, and all are there, assuming that's the zero state, the first level one, is the AAML solutions. And the second level basically is the generative AI. What are the generative AI is doing is it is able to actually do plenty of interpretation of the text. I come out with a univariate model, or I come out with a bivariate or a multivariate or output model. So how I'm going to interpret that? But these two levels are deterministic. So here, you catch me once you understand this. Rest of it is very, very simple, and we can get into detailed chart and see what sort of problems you have, and how you are planning, how we can actually become part of your plans to get into this. We can see. But if you understand this, uh, level one and level two, now they are told they are deterministic models. Actually, any AML model is deterministic. What I meant by deterministic is I'm estimating my next 6 months sales. I'm on April, whatever, today, I lost, actually. Today is 3rd or 4th, I think. Okay. Today is 4th April. There. So now I want to estimate my sales at corporate level, take that estimation to the lowest granularity, for the months of June to, say, for example, December 2026. I have past historical sales data, and I also know the factors which we can call them as variables which influence my sales. So I've collected all the data, and I have, of course, I am not going through the AML life cycle here. In fact, we are going through the agentic AI life cycle. So I'm not going to say that, but of course, we need to actually clean the data and allow the data to be consumed by the algorithms and come out with an output, and that output gives a number. It says, okay, May your sale is going to, June your sale is going to be 200 tons, it says. It is saying based on my past historical sales as well as the factors I have taken like price, seasonality, discount, quality of the material, the spread of my sales force, so on and so forth. So all those factors we have taken into account, and accordingly we have estimated it to be, say, 200 for June. But what happens from now to, say, May 31st or June 1st or June 5th? A lot of things would change basically. A lot of things would change. So, how to factor the changes in the variables we have considered, and we have given some values, and what would be the impact of the changes to the values of those variables to the 200 number? That's very, very important actually. So that is the next level. That is level 3. That is what a demand planning agent would do. So far, what I'm saying is I'm only saying a demand forecasting model. Now, what I'm saying is, hey, I'm having a demand planning agent. It is actually simulating each and every aspect of the variables, not just internal, external. Say, for example, it is taking the current geopolitical conditions into account. It is able to do some sort of estimation, and it would actually keep revising its estimation based on what is happening on an hourly basis. Say, for example, how we'll talk about it as we go along. We have several slides on the technical side also. Then it is able to say exactly whether it is going to be 300 or 290 or 310 or 340 or whatever it is. Okay. So move from prompt response to global goal driven execution. So this is what actually, that is level 3. So level 1 is AML solutions, level 2 is Gen AI, level 3 is basically we are talking about AI agents, and level 4 is agentic AI. This is how we know. Having said that, let me tell you very frankly, I'm in this advanced analytics from 2012-13 onwards. Not many companies, including very big companies, still haven't exploited the potential of AML. So where you would like to be, where you want to start actually, I really want to explore the potential of AML solutions, build some forecasting models, build some optimizers, and then actually, move into the next level. Or I want to actually go straight into AI agents and build some agents and enable plenty of, coordination and collaboration between those agents. All that actually, varies from company to company. Okay, this is what is agentic AI. Now, what's the time? Because it's 11:07, means
We
11:37.
have we here Indian time is 11:37.
11:37. Yeah, yeah, correct.
Yeah,
Okay.
correct,
So
correct.
we have time up
You
till
have a time. Yeah, yeah.
12:15.
Please
Yeah.
go
I,
ahead.
I,
Please
I,
go.
I speed up a bit actually. Okay. So why
Okay.
agentic AI matters now? It's common sense basically. Yes, I need to create a sustainable competitive advantage for my company. I need to differentiate myself. There has to be a real competitive strategy. I need to catch up with competition. So for which I really need to get into a real-time decision making, and not only real-time decision making, there should not be any hurdles towards implementing the decision. That is actually called autonomous orchestration. Now, the model takes a decision, but there is nobody to say yes or no. Or, if human comes and uses his, hierarchical power and overrules that. No, here we are actually giving complete, power to agentic AI through, of course, AI agents which are collaborating amongst themselves. Okay. So if you see the other point, explosion of enterprise data, need for autonomous interpretation. That's what I told, few slides back. So this is what is this. Now we'll go to the next slide. Okay. So where we start actually, okay, I'm talking about, AI agent and agentic AI. Please remember this. These two are different. AI agent is one agent. AI agent is a domain specialist. I'm having a demand planning agent. I'm having an inventory agent. I'm having a maintenance agent. I'm having a planning agent actually, but we are working on IBP and we are doing it very, very well using a planning agent. You all know what is IBP, integrated business planning. So, like that, there are so many agents. Same, we're all working in different companies. Somebody in sales, somebody in marketing, somebody in production, somebody in finance, somebody in maintenance, somebody in projects, like that, So, but what happens when we are working as individuals, when we are working in different departments? The collaboration is there between these departments. I won't say it's not there, but the way it should be, because I'm always concerned about my department. I'm not able to think, there is a change in my department. Say, for example, if there is a change in my demand forecasting number, what that change means to my procurement, what that change means to my production, what that change means to, say, for example, to my profit margins. So they all come together. They quickly actually, collaborate amongst themselves and arrive at the best decision. What should be the best decision? Hey, since I'm not able to sell much, I need not produce. Because I need not produce that much, I need not procure that much. So instead, immediately, they negotiate with the suppliers. These guys, they are capable of negotiating. They negotiate with the suppliers and say that, I don't require that much actually. Okay. Or they see a price dip. Another supplier is giving it a different price, they'll definitely go and say, hey, the price has come down. You need to give me at that price. So on and so forth. Or they are seeing, the maintenance agent is seeing an impending machine breakdown. In 2 days' time, he sees the machine may come down, may fail. So then immediately he would go and talk to the production agent. The production agent will talk to the procurement agent, so on and so forth. So all of them together, what they do is they actually do a network optimization. So what is the goal capture? The life cycle. This is very, very important. Where we start, how we start. We need to have some sort of, okay, I want to build a demand planning agent, or I want to build a maintenance agent, or I want to actually bring my cost of goods manufactured by 10%. I'm just giving my KPI target. It is taking 16 rupees 50 paise for me to produce 1 ton of my finished good. I want to reduce it by 10% is 1 rupee 65 paise. So whatever it is, 15 rupees 55 paise or something like that. Okay, 15 rupees over 5 paise. Okay, so I want my cost of goods to come down by that much. So, yes, that is what should happen. Or the constraints, hey, I'm operating with these constraints actually. Given these constraints, how we are actually optimizing my network, how we are actually predicting, how we are simulating, and how we are creating a digital twin and enabling the digital twin to work with my multi-agent system to act and coordinate. So that's the second. This thing is, once you have that goal, as it is, your ERP implementations also, you have as is, what is as is, what is to be, what is business blueprint, how you are going to realize the to be process. You all know that actually, correct? Here also some life cycle. Otherwise, you are very, very familiar with SDLC also. So goal capture, perception. So what is meant by perception? Okay. So it is actually sensing. So most important is this agent is so powerful. It is actually sensing. Perception is basically sensing. It is sensing data not only from internal sources, it is sensing from lot of other external sources also. So when it is sensing, what it is doing is it is actually doing plenty of reasoning and planning. Okay, we are empowering that agent with that much of brain actually. Okay, so it is perceiving, it is actually doing plenty of reasoning, and then it is acting actually. I told you, PRALC, I told, correct, So reasoning and planning, then the rest of the steps I won't go through at length. So action, execution, evaluation, and learning, and the cycle goes on. Okay. So one agent doing one function, another agent is doing another function. So we have deployed, say, for example, four agents, all four agents working together, intra and inter. Intra is within their jurisdiction, inter is amongst themselves. Demand, procurement, uh, planning, and say, for example, maintenance. These four. So they are immediately seeing, what would be the impact there. That's why I told supply chain is a circular. It is not actually linear or something like that. It is a circular supply chain. Okay. So this is the life cycle. So again, because I'm going to give it to you, I'm seeing a time problem now. So, how actually agentic AI is enabling real-time autonomous decisioning actually. So, in fact, this is both a bit of functional as well as technical. So, it's not that easy as I explain the slide, but the power of this is actually here. This agentic AI is enabling real-time autonomous decisioning. Okay. So how it is doing is with all the previous steps I've explained, because it is perceiving, it is actually sensing, it is no, um, it is actually doing plenty of reasoning. So
taking
okay, the war
action,
ends, the war don't end. If this port opens or if this port is not opening, so what is the best way actually? Like that, that's why simulation is what? Simulation is it's a huge conditional probability matrix. I'm looking at thousands of options actually. As a human being, it would be impossible for anybody to look into all those permutations and combinations also terms sometimes, not just only a combination, sometimes permutations also. And working. And when I say closed loop means closed loop integration with ERP and operational systems basically. Yes, it is not just one way. It is taking data and it is again instructing what it should do. It enables a ERP system to do a PR cancellation, or it would enable it to do a GR receipt, so on and so forth. Okay. So what it means is basically from reactive to proactive to predictive. In fact, we need to extend this, predictive to simulative to autonomous. That's the one. Okay. So as I requested, we'll talk about all this once I complete. Then, what is the architecture at a high level? You start with integration and data layer basically. Yes, you can take data from all sources, internal, external, everything. How we are going to ingest the data, all that most of you must be knowing it actually. Then we have this agent layer. Okay. So planning, execution, monitoring, and optimization. So it has its memory. We have a lot of tools. I'll show you what are those tools and what are the skills that are required for this agent. Okay. We are going to arm an agent with memory, uh, of course, mostly, normally we use this lang chain framework, and of course, what are the skills that are required. And the cognitive layer is above, above the agent layer. We have these LLMs, we have the reasoning engines, and we have the planners. And of course, the experience layer where the action takes place automatically. Okay. So this is reference architecture. It would be impossible for me to cover from both functional perspective as well as from technical perspective in one hour 15 minutes, but definitely we'll have more sections as we go along. So here, I have given a bit of a detailed agentic architecture. Okay, whatever I have explained, but I just put this. Most important is once I have actually come out with a goal, and when I split that goal into a lot of activities or tasks, then it goes to orchestrator, and that orchestrator actually creates a system of managing a multi-agent workflows. Okay, so this is how it goes. Then the technology stack. Okay, you all must be knowing about this technology stack, I'm sure. Definitely some of you must be learning, say for example, a lang chain, or you must be familiar with one ERP system. Okay, here we have put just SAP BTP uh, as an example, because I come from SAP background. BTP is business technology platform. You all must be knowing, whoever knows SAP, they know what is data. Okay, so this is the technology stack. And the data sources, basically. Yes, as we talked about the operational systems, the transaction data, the master data, the external data, the unstructured data. Okay, again, just a few examples here. The sky is the limit, actually. Again, depending upon the type of domain we are in. Are we a pharma company? Are we a oil and gas company upstream? Are we a bank? Are we into insurance? Depending upon that, actually, we'll be looking at the data that is required from both internal and external sources. Okay. Again, of course, not just the domain, the goal we have taken, what agent we are building. Okay, within domain, HR domain is totally different from a demand planning agent domain, like that. Okay, how it is interacting with ERP, all of you must be knowing. I'll skip this actually. In any case, it will come to you, this deck. Okay. And personas, who are all the people involved here actually? Who are the business persons, of course, again, because we are talking about supply chain, I just mentioned about supply chain, procurement, finance, and operations. If we are talking about HR, the HR guys, and the technical persons here, and the digital workers. So these are the agents. Each one is an agent here. Okay. The planning agent, the forecasting agent, the exception resolution agent, actually. Okay. So we also have, so if there are some problems, actually, we go to somebody to resolve it, or there is an exception, actually. We all know about, alerts and exceptions. Okay. We do plenty of what if analysis, correct? So these are all the personas involved in this. This is a platform, actually. We are just given this. This itself is a separate topic by itself. How we are going to have actually agentic AI platform. Just a overview how that platform is going to handle all your agentic AI needs. I won't say requirements. Starting from injecting an idea into you to actually creating that agent. Okay, so the business impact, of course, these numbers we have taken it from some sources, but the numbers in reality are more powerful and mind-boggling. Actually, they are too good to believe. Also, like that. Okay, so this is what an agentic AI in nutshell. An agentic AI is nothing but a multi-agent system wherein several agents, they come together, they collaborate, and they do a global optimization, a global prediction, and whatever they do, they implement it actually. What is that? Autonomous orchestration means autonomy. It's just not automation. Transaction automation is totally different from uh, arriving at a decision and implementing the decision. So agentic AI does that actually. Okay, so you can remember this actually, from automation to autonomy to autonomous orchestration. That is actually conglomeration of agents coming together. They collaborate, and I already told you, what is meant by that perceive, reasoning, and acting is the most important. And after acting, actually, adaptive, it is learning, and it is also communicating. Obviously, it has to communicate. Okay, now I'll go through very very quickly, because we are already at 11:53 your time. We have only 20 minutes. So in supply chain, you all must be knowing about, we talked about supply chain a bit, actually. uh, Supply chain from a 360-degree perspective, supply chain having a ERP system, having some sort of local optimizations and local predictions. uh, they are necessary, but why they are not sufficient, and the need to actually have different agents deployed across my supply chain to do all these functions, not only actually do their domain functions, but also they should come together, act in unison, coordinate and collaborate amongst themselves, and do what is best for the company at that point of time. Okay, so it is beyond automation. Agentic AI autonomously plans, decides, acts, adapts in real time, anticipates disruptions, and executes corrective actions without human intervention. Okay, so in supply chain, so rest all is straightforward, actually. We talked about several areas here. I don't want to get into the subject per se into supply chain, um, but you all know basically. You start with a demand. Let us actually, I'm actually covering 10-15 slides, so you can take it like that. So you have demand, and you have demand forecasting. Okay, so when you have demand forecasting, I told demand forecasting is a deterministic number. Now, demand forecasting, I have forecasted based on how I thought the factors, the influencing factors would behave, and what values they assume. So, based on all that, I have arrived at a number. Now we know the reality could be totally different. So, if the reality is different, there has to be a mechanism of changing this forecasted number, and say that this would be the demand for this product in June. And not only that, because of this change, there has to be a lot of changes across all other related functions. Not only that, suggesting the changes, but basically we should actually implement all those changes. Like I told, you are going and negotiating with the suppliers, you are going to talk to the customers, you are actually, seeing a breakdown in 2 days' time. You are looking into the spare parts inventory, and if spare parts are not there, you are going and ordering the spare parts. Or if you think that we call it as RUL in AML solutions, assessing the remaining useful life of the machine. If you think the machine is working okay, but it won't last more than a year, then actually you are planning like that. Warranty, without warranty, transport, the contractors, the routes, there could be route disruptions. Okay, one route is closed, what I should do, so on and so forth. Each and everything basically. Or project financing. You are expanding your capacities, and you think that the capacity expansion would be done by August, but you are seeing delays in the project execution, thinking that it would be done by August. You have anticipated certain number of additional customers to be acquired. Now you are actually getting delay in the project is getting delayed. So what you are going to do? You are going to actually slightly postpone the discussions with those customers for additional quantities. All that these agents would do. Like that, we have so many agents here. So you can easily understand all this. I told you everything actually. So your replenishments basically, retail execution and demand shaping. So you have a retail agent, you have some 100 retail stations or 100 supermarkets, whatever it is basically. So how to monitor the stocks, which is fast moving, which is not fast moving, how to plan replenishment. So what you should do to basically, maximize the sale of a particular product in a particular retail outlet, so on and so forth, all those things. So here the most important thing is these were there. We were talking about these things during AML solutions also. When I say AML means, not long back actually. Okay. Not even 3, 4 years back. Now, everybody started talking about traditional AML. So, but now what we are saying is the difference is whatever, we are able to arrive at a much more powerful decision, a broader decision. Not only we are arriving at a broader decision, but we are able to actually implement that decision without any human intervention. That's the crux. Okay. So these are all the things. Most important is this autonomous orchestration. So please go through. If you have any doubts, you can reach out to us anytime. Absolutely. Why I'm skipping is you're all supply chain guys. You must be having plenty of domain experience. Okay. So yeah, in fact, even before this agentic AI supply chain operations and management as an application we started developing, we were working on a subject called supply chain visibility, responsiveness, and resilience. VRR is basically, that visibility, responsiveness, and resilience. To what extent, I'm getting visibility of my demand in my supply chain actually. Okay. Next month, if I have to sell 500 tons of a product, on first of the month, how much I'm seeing? Am I seeing 100 tons? Am I seeing 150 tons? Or am I seeing zero? Or am I seeing 400? That's very, very important. So what sort of visibility I'm getting? And for rest of the quantity, okay, if I'm seeing 100, the balance is 400 because my demand is 500. How my supply chain is going to respond? Supply chain responsiveness. First R is responsiveness. What is meant by responsiveness is my ability to produce 400 and my ability to procure the raw materials that are required to produce these 400 tons. Okay. I'm saying raw materials that are required and my ability to bring those raw materials into my system, produce and ship the finished goods of 500, 100 plus 400 to my customers. So that is entire supply chain. What is the responsiveness of my supply chain? And what is the resilience of my supply chain? Okay, if anything goes wrong here, if anything goes wrong here, what set of resilience that is there in my supply chain? Because at the end of the day, as I told in the beginning itself, the most important task for the entire company, at least from a tactical perspective, is GATP, Global Availability to Promise. It's called order fulfillment or, adhering to the delivery date that I have promised to my customer. That's the most important. Then I need to work backwards. Okay, I told I'm going to supply this much to you on 15th June in your warehouse, where I told that. So from 15th June to, I need to start work backwards, start from 4th of April. What is that I need to do? That entire planning I need to have and execute that plans without fail. That is what actually, whether, anything can go wrong. Some supplier may not, give me the raw material, or my plant may break down, or there could be a transport strike, or all of a sudden, if I'm using gas for a commercial production, say for example, gas is not available due to some other reason. But what sort of resilience I have built in my supply chain to overcome all this to meet that 15th June deadline. Okay, so we build that application actually. Of course, part we have built, part of that is in a framework, but now we know this SCVRR is nothing but more or less talking about the agentic AI approach. If I'm able to do a proper synthesis and rightly align this SCVRR concept, it is becoming agentic AI. Okay, so that is where I've used self-optimizing factory. I've used, now we are using actually self-optimizing supply chains. Okay, so the dynamic decision making, not just dynamic decision making and actually acting. So this is SCVRR. So I'll just go through very, very quickly. In fact, if you see again how this is there, agentic AI at the core, and how it is doing a real-time monitoring, and it is doing a predictive modeling, and it is triggering the actions, and it is actually continuously refining and going on actually, in a circular way. If you see the picture there. So let me go through this very quickly. You all know this. Okay, I see. To since I know that I really want to give this deck to all of you. uh, some effort we have put in. Okay. That's why I've completed this from all aspects actually. So there are so many slides. I'm skipping some of them, which are self-explanatory. Okay. Yeah. What it would do, all this. See, this is very, if you understand this, many times we're talking about, last 45 minutes, detect early signals of disruption, early signs of disruption, actually. So the agentic AI, actually, it is detecting early signs of disruption, recommend or execute contingency plans. Yeah. Say, for example, a transporter is there who is giving me 100 trucks. I have a contract with him. For whatever reasons, actually, this transporter has entered into a contract with some other party. Say, for example, and his plan is to divert out of 100 some 30 trucks to that company. Our AI agent would know. How you would know? Don't ask me. That's how we actually build the agent. And then immediately we'll say, hey, look, this guy is going to give us only 70 trucks. We need to start straight away talking to another contractor. So we are talking. So we need to enter into an agreement. So that's what I told, the guardrail. Wherever it is required, under exceptional conditions, wherever it is required, human intervention, till that time, actually, it would do whatever it has to do. So simulate alternative scenarios, the same thing, alternative scenarios. Same, you can actually, easily bring plenty of analogies to demand, inventory, production, maintenance, inbound logistics, outbound logistics, customer service, so on and so forth. Okay. So this one example. Yeah, now we will get into the next one. A lot of slides are there, but I've told a lot of these things to you, so don't worry. So this also I told you. Okay. So these are all examples actually how it is the triggering actually. Problem in procurement, what sort of problems it can actually trigger to production, to logistics, to inventory, to order fulfillment, like that. Or there could be a problem in my order fulfillment. Okay, order fulfillment basically, the customer says instead of 15th, he says I want it on 12th, or he may say I want it on 20th. Okay, so since he requested for a change in delivery date, so what sort of uh, change in actions required in procurement, in production, in inventory, in logistics, so on and so forth, all that. So they all quickly assemble, they look into each and every aspect, quickly take a decision. Yes, we can supply to this guy on 12th instead of 15th, like that. Okay. So imagine if we have to do that, how much of effort we have to put, and even then we can't actually come to any logical conclusion. By the time 12th would come and go, but still we will be having a lot of meetings on that. But here, these agents, intelligent digital teammates, workforce, whatever you call, okay, they do all these things. Okay, this one we have, this thing will go now. I'll take you directly to this. Okay. So we talked about, so far we talked a lot about agentic AI, means basically multi-agent systems actually. Agentic AI is nothing but multi-agent systems. We are talking about several agents. Okay. Before we talk about several agents, I'm sure you all know what is meant by an agent actually. How we build an agent, what sort of technology stack we require, what sort of architecture that is required, okay, how we can make best use of an agentic AI platform, how we deploy that agent, how we operationalize that agent, okay, what is the life cycle of that agent, all that. Now I assume that I have several agents like that. There is a production agent, there is a logistics agent, there is a storage agent, there is a retail agent, like that. Okay, what it is doing is it is actually bringing all these four agents. It's called multi-agent systems orchestration and optimization. Okay, so we'll go to the next slide here. We'll spend some time on this. Okay, why you require actually MAS? You all know supply chains, yes, they are very, very complex, pretty volatile. The entire current, future, everything. You are at 12:10. I have another 5 minutes, correct? Yeah. You are at 12:10, correct? Yeah. Yeah. Okay. So we know this actually, correct? So this you see, um, uh, the complexity and the volatility and what sort of solutions we have in the form of AI agents, and how these AI agents actually combining with this digital twins. I told what is meant by digital twin are self-driving operations. Autonomous is one more thing, self-driving operations. So for example, here day in and day out, we are traveling every day. uh, uh, though a person is sitting in the driver's seat, he is as free as we all chat, and the car is going beautifully, absolutely, it is sensing everything tremendously. So self-driving operations. Similarly, assume a situation where there are a lot of agents in the company, and they are all taking care of all the functionalities. Uh, and I'm coming into picture where I have to come. Otherwise, I'm focusing on some really strategically important aspects of the company, of the business. So I told you this, pursue their environment, make independent decisions, collaborate with other agents, learn continuously, optimize both local and global objectives. I told you, MAS means it's a global optimization, a digital workforce running the supply chain, basically. Okay. Now, I told you this one, PREALC actually, perception. Okay. So it is perceiving, it is sensing, it is reading the data. How it is reading data, how it is knowing what is happening, how it is doing interpretation. Okay. Beyond anyone's ability, all that depends on our constructing the agent actually. Okay. Then reasoning, how you are empowering that actually. Okay. Then, of course, action executes tasks autonomously. Then it is learning with experience. Okay, adaptive in nature. I told, correct. It is learning. It is seeing actually from the past. Same, any AM model, AML model also learns actually. Here also the same thing. That's why I told from level 1 to level 2 to level 3. Level 3, level 4, we talked about agentic AI. Level 4 has 1, 2, and 3 plus plenty of delta. Like that, we have to see. It's not that agentic AI has come and, displacing my ERP or displacing my process control system or displacing a SCADA. No, it's not like that. Okay. Then communication and, it interacts with other agents. Needless to say that point. Okay. So it has all these layers. Okay. So again, you need to know those who are in a technical field, techies, they have to go deep into this. Uh, Otherwise, with the plenty of domain experience, they should be really thinking about the variables, what sort of, varying values, at what frequency these variables can take, like that, we need to think, because that's the most important aspect of building an agent. So what are the different agents actually? Reactive agents, deliberative agents, learning agents, collaborative agents, competitive agents, and hybrid agents actually. Okay. So again, an agent, to be quite frank, will have all these characteristics. It's not that, to be quite frank, um, intra and inter. So it has to collaborate. Okay. When it has to act, actually, it has to negotiate and bid depending upon what type of, domain expertise that agent has. So a agent has to have all these characteristics. So these are all actually they take care. Multi-agent systems in supply chain, the key domains, we talked about all this so many times. Only thing so far I haven't talked about is the sustainability and ESG, environment, safety and governance. Customer experience, though I haven't directly talked, I mentioned about it several times. Otherwise, we talked about all these domains. Okay. So these are the agents. Probably I talked about all these things, okay? Except for here also the same thing. The carbon footprint agent we haven't talked. Otherwise, I talked about all this. So each agent solves a specific operational problem. How MAS works is basically, yes, start with one. So agent sense disruptions, demand shifts, delays, etc., etc. Again, you need to understand the sentence with respect to what agent you are talking about. If you are talking about a demand planning agent, yes. If you are talking about a supplier agent, if you are talking about a maintenance agent, so on and so forth. Okay. How we know a maintenance agent sense disruptions? So we are having condition monitoring. We are on a continuous basis monitoring the health of the machine. So the health of the machine depends on, say for example, 15 machine functioning parameters. So we are getting the data and what OEM is saying. Okay. OEM says, the value of this particular one should not exceed. So we continuously monitor and we actually automatically, the model uh, mm, uh, looks into the probability of in 2 days time where this value could be. Is it going to exceed the OEM prescribed value? So for example, you take heat itself. So when the machine is functioning, the OEM says actually the temperature should not exceed 150 degrees centigrade. So we are continuously monitoring, 148, 146, 149, okay, depending upon the machine load. Now, at this rate, if the machine load is going to be this much, probably the temperature can exceed 150 in next 3 days' time. That is how we do the condition monitoring. So that is what is actually, once it exceeds 150, probably there is a good chance of the machine breaking down. So that is what is disruption. So I just gave one example with respect to a machine. You can think of, so many examples across the supply chain with respect to demand, with respect to inventory, with respect to inbound logistics, outbound logistics, MRP, material requirement planning. In fact, not many people talk about MRP and BOM optimization. line item wise, aggregated BOM line item and accordingly procuring. So it has a huge cost implication. So to produce a particular product, I need five raw materials. So I'm having, line item one raw material, line item two, second raw material, so on and so forth. Now, for line item one, raw material one, I'm having five choices. Which choice I should exercise at this point of time? Or I'm producing another product for which the same raw material, line item one raw material is required. So how I'm going to aggregate the demand of all this line item one raw material requirement and negotiate with my supplier. So that is actually, BOM optimization. Okay. So how it happens if you see, so sensing a disruption or sensing actually demand shift, sensing delays, then what are the optional actions? Okay, if this not this, if not this, this, if not this, this, like that, the agent decides, then it communicates with other agents actually, then they coordinate to avoid conflicts. Okay, then agents execute actions autonomously. Agents learn from outcomes. This is how actually, again, easy to understand as a concept, uh, not that difficult or not that easy to apply this to our real work scenarios, but definitely, calls for very, very good domain and technical acumen to build agents actually. Okay. And the power of that is absolutely, they are going to rule. Absolutely. That's why, when everybody says AI is actually, going to disrupt the entire world, means basically they are talking about agents and agentic AI in all walks of life, actually. Okay. So this is one example, port delay detected. Let me see the time. I really don't want. 11:50 means you are at 12:20 now, correct? Rajgaru?
Yes, 12:20 now. You
Okay.
can,
So
with
I'll stop
briefly,
this in
yeah,
2-3 minutes time. I'll stop this in two,
yeah,
3 minutes time. Yeah.
yeah,
Sorry,
yeah, yeah.
actually,
Please go ahead.
this is going
Yeah.
on. Okay, this you can read it, you'll get this thing. In fact, this is very, very timely example we have given, port delay detected actually. Yes, you're all familiar with, um, what is happening currently, and where this if anybody is from oil and gas background, I'm from oil and gas background, I boarded a lot of tankers and discharged a lot of tankers actually, so now LPG is a problem. We, net importers we are, and we are not able to import now, even if we are ready to buy, if somebody is selling, we are not able to bring that to our ports. Okay, there is a port delay detected. What you should do? Okay. Yeah, I say generally agents can handle near abnormal also, but if it is real abnormal, yeah, okay. So don't let us not think that agent has all the answers on earth, but definitely yes, uh, infinite times capable of humans. Yeah, this is the last slide. I'll stop actually. I told you. So this is very, very important, MAS, I told so many times, you all must be knowing by this time, multi-agent systems plus digital twins. So synergizing for a self-driving supply chain. Okay. They both are coming together. They are forging synergy amongst themselves. What digital twin do? I told you SPO, simulation and production and optimization. What is MAS doing? Execution, coordination, and autonomy. Okay. That autonomy is the most important thing. Without autonomous, we have some very, very good AML solutions. That's why we always start with exploratory, then we go to descriptive, then we go to predictive, then we go to prescriptive, and we end up with autonomous. So this is what we used to talk last 10 years, but we always used to stop at predictive level. Prescriptive, Yes, though we prescribe, the customer has to subscribe to it. But now we know we cross the prescription to the extent without any intervention, autonomous state these solutions are getting. Okay. The integration of real-time simulation and autonomous execution drives unprecedented efficiency and resilience. Okay. So what are the benefits of this? So many, just few, and how you are going to implement this, identify for your company, since most of you are coming from MSME. uh, yes, definitely, uh, IPQC will be helping you in identifying, where to start. Actually, we can start with, probably one agent, gain the benefit, slowly build another agent, then, create, collaboration between these two, like that. Slowly, slowly, we can completely bring autonomous orchestration. The other great thing with the agentic AI is when you are doing autonomous orchestration, you're also bringing process orchestration also without your knowledge. Like if you implement ERP, particularly SAP, because I'm a SAP guy, when you implement SAP without your knowledge, automatically, you are adapting to the industry best practices. So here also the same thing would happen. So this is the future state vision. So the last one is a very good sentence, it becomes the operating system of the future supply chain. Yes, actually, yes, So what is meant by a future supply chain is it is predictive, it is self-optimizing, it is sustainable, it is self-healing. Most important is self-healing. On its own, it would bounce back. On its own, it recovers actually. Okay. That's the key aspect. Of course, autonomous. So this is the summary. Reactive to autonomous, a big jump actually, MAS transform supply chains from reactive to autonomous actually. It's a jump of, 1 to 100. All of a sudden, somebody who is getting some 2 marks, 3 marks, with this, he is in the top league. And then real-time optimization. The future supply chain is self-driving, we talked about. Yeah, so this is what now. So this is, of course, some additional slides. Yeah, long presentation. Thank you all. My time is almost like, 12 a.m. now in the midnight.
Yes, yes, sir. Can you stop this slide, sir, so we can ask
Yeah, I will
people to ask
actually.
questions? Yeah.
Yeah, sure.
Okay. So, any questions from the audience? You can directly can speak to the.
I have one question. Hello.
Yeah, please go ahead and ask.
Okay, I built a workflow for which can send email reports from a CRM and Slack channel. So how can I convert this into this is a workflow automation I know, but how can I convert this into agentic AI?
Yeah, we'll discuss that. That would, call for a sort of design. Absolutely. Okay. Is it Harish?
Yes.
Harish, yeah,
Yeah,
Harish,
yeah, we'll
Harish.
definitely discuss Harish.
Harish will take up this and will give
Monday
the
itself.
time to other
Monday
members.
itself we'll
Yeah.
discuss. Okay.
Yeah.
Sir.
Any other members? Any other members want to ask? Please ask. And they very nice, sir. It is really great presentation, and you so simplified is so much, content you compressed, and really building agentic AI is not an easy task in a real world, and it's so complex. And really, you are creating a brain, for the organization. Supply chain brain you are creating, so it is like it may replace many managers, supply chain managers, if they are not learning AI. Definitely, definitely they lose the jobs, and it is a big threatening for those people who are in the supply chain, and they need to acquire the skills and start building the agentic AI things in their organization. So, oh, very nice. And We'll be sending a feedback form, and please fill the form. And if any questions, you can write to us info@ipqc.in. We are continuously exploring a new emerging technology topics. IPQC drives the new technology related topics and taking this to the MSMEs across India. Basically, our aim is to bring the technology to the doorsteps of MSME, and many people, especially professionals, building the competencies, and we are bringing experienced people from various across the world. We are trying to connect through this platform, and I take this opportunity to thank all the participants. And if any question is there, any question from Naidu, are you
Yeah,
there? Can you ask?
yeah, yeah,
Yeah, please go
yeah.
ahead. Yeah,
I want to ask,
yeah,
Vijay
please go
Kumar.
ahead.
This see, we work in the area of MES and predictive maintenance. So we generate a lot of data from sensors, mainly from motors and gearboxes, which is 4 or 5 parameters continuously come into our platform. So how we can build a predictive maintenance agent so that you can build you can predict the failure and advise the maintenance teams.
Yeah, sure. Not only advise the maintenance teams to even, initiate actions actually. So this is a standalone agent you want to build, maintenance agent. 100%, can we get into a detailed chart on Monday?
Okay.
Sure,
Yeah.
we'll organize the
Rajgaru, please
discussions.
facilitate.
We'll
Please facilitate
we'll
this
we'll we'll do that.
because
We'll do
we
that
have built a lot of
definitely.
AML solutions um, in predictive maintenance. So we just need to extend this into an agent now. That's why I use a lot of examples, correct? Condition
And
monitoring, assessing the remaining useful life of the machine. Then we also worked on actually time-based to risk-based maintenance schedules. Okay, just because the OEM told you need to do servicing on so and so day, uh, if it is not required, I need not actually do the servicing. So it is called
Okay.
time based versus risk based. And we also worked on digital twins. Digital twin is actually cloning that machine and subjecting that machine to plenty of sensitivity. So yes, from that state, from a AML solution perspective, we have done several. Now we need to advance that into the agentic framework. We'll do that definitely. Yeah.
Definitely, we'll be having a separate
Yeah.
discussion.
That's
Especially
very
you are
good.
already in the industry
Where you
core.
work, which
Definitely,
company you work, Naidu Garu?
sir, I associate with a company called Industry Apps. We are into MES system and predictive maintenance solutions.
Oh, okay.
Mainly, we have not gone into use of AI, but we are putting the IoT sensors and
Hmm.
generating the
Okay.
data and alerts based on that data.
Okay.
So we are at that stage only. So we want
oh,
to
great.
improve ourselves.
Sure,
Great.
definitely.
So Vijay Kumar definitely can help them to become a Agentic AI company.
Correct.
So
Yes,
definitely,
slowly.
we'll,
Maybe first we'll have some predictive maintenance solutions and then
yeah,
build
yeah,
a
yeah, yeah.
maintenance agent gradually, actually.
Okay.
Okay.
So,
Right.
okay. Any other questions? Can we close the meeting? Any other thing? Any other member want to ask any direct question?
So
Any
thanks,
other
everybody.
question from the? Thank you so much for your participation and active listening last 1.5 hour. It is a really, really fantastic thing. I really like this personally, this topic, because this is the what driving entire world now. So we need to focus on this, and definitely many companies in India are going to adopt this silently, and a big way they are going to gain an advantage global supply chain. So hope it will. It is very useful for the Indian companies. Thank you so much for your time.
Thank you,
Thank
Vijay
you.
Kumar
Thank you.
garu.
Ah,
Bye. Bye.
yeah.
Thank you.
Thank you.
Thank you, Raju Garu. Thank you, Vijay, for a
Thank you.
wonderful
Thank you.
presentation and taking time to explain it very clearly and precisely. I really
Ah,
thank you.
thank you so much, Rajesh. Thank you.
So I'll connect
Thank
with
you.
Raju Garu. I'll
Sure,
want to.
sure, sure. Definitely we'll connect. And if you are having any specific questions, you can write to us info@ipqc.in. You go visit our website,
Sure.
ipqc.in. or you can write to us info@ipqc.in. You can get the
Sure.
details. Okay,
Sir,
thank
we
you
are
so much.
building agents for pharma industry. Are you dealing with pharma also, sir?
Vijay Kumar sir is from pharma background. He had a lot of
No,
experience in
I
pharma and
know Vijay
chemical
sir.
industry.
Actually, I'm
Uh,
asking like we have tried like couple of agents for pharma industry also.
okay. But
So
definitely we'll try to connect what is your issue related to agentic AI? Is
yeah, we are
related to
looking for more like pharma industries to go and collaborate and do that work.
okay, okay.
We already have
Uh,
agents with us.
Please, can you write a mail so that I will route it through the appropriate team in our group and we'll come back to you. Is that fine?
Sure, and sure,
Uh,
sure. I'll discuss with Vijay.
info@ipqc.in. Please
They will be requiring
drop
an
your
email
mail.
automation agents.
Yeah.
That is a company-wide. So it means that every company wants that nowadays.
Yeah.
Yeah.
Okay. Okay. So we'll conclude this. We'll thank you so much for your active participation. Thank you, guys.
Thank you.
Thank you.